we talked about the pros and cons for both sort of classifier-based standard machine learning techniques and deep learning techniques. And we identified few sort of cons, let's see where, for this deep learning type of approach, because this is a relatively new, novel kind of idea. I want to kind of a little bit go one by one these issues and maybe show you some. These are the only kind of new results I'm going to show you today. Some new results which might tell us something about, I mean, not new, but something which you didn't see before. Results which might sort of a little bit mitigate and give some hope and maybe sense of direction in which one we can actually address some of these issues. So, for example, the first note was that we need quite a lot of data for these deep learning models. But as we learned on our own database, we don't need huge amount of data. We don't need huge amount of data to get sort of meaningful, interpretable, and hopefully relatively robust results. Well, meaningful and interpretable results we got from our own data. Robust, we don't know. How can we figure out whether the results which we get are sort of robust, or are they depending on particular samples we collected? We were talking yesterday, Tuka was talking as well, about the sort of difficulties with, assessing what type of characteristics the given recording and given even speaker has. We're talking about the language label like English. Sort of it's weird. All of the Englishes are put together, or Russian. It can be Russian who grew up in St. Petersburg, almost walking distance from Finnish border, and might speak Russian one way, and then the Russian who grew up in Kamchatka, walking distance from Japan, as a matter of fact, or swimming distance from Japan. These would be classified as the sort of same type of language. Maybe it is, but we don't know. It's sort of so. How robust these type of results might be to this type of variation, which is inevitable in any data, and it doesn't have to be this crazy variation. Just pick different speakers, for example, or different samples. What happens? So we did test this for our world languages experiment or analysis. So you've seen this type of a pterodendrogram. This is a similar one. It's a different one to the one which I was showing you earlier. There is fewer languages, as you can see on that, and there are some numbers attached to those edges, to those sort of joining lines. So this is called consensus tree. So what we did, we only used languages which had at least 1,000 samples in a database for this particular purpose. That meant that we ended up in, if I remember well, 79 languages as opposed to 107. So those 30 odd languages had less than 1,000 samples. So we had to limit it to 1,000 samples. Why? Because we build the trees. We build actually 20 trees from 50 samples from each of the languages. And we made sure that those samples didn't even overlap. So we divided those 1,000 samples for each language randomly. We mixed them randomly to 20 50 sample bunches, and then built the tree from the 20 trees from these 50 sample portions. And then there's a technique how we can compare the resulting trees. That's called consensus tree. So this is essentially the tree which has these edges on more than a quarter of those examples, as a matter of fact, and it gives you the number at each edge in how many kind of trees the set of the languages following the fork all the way occurred. So for example here, you can probably read it, neither can I really, but here is like 25. That's not a very high number, but it means that in 25% precisely Mongolian and Abkhazian were put together like this and nothing else. In all the others, maybe Mongolian was somewhere else or some other language got into that. Nevertheless, we can see that we get relatively robust relationships. So whichever sample you take, you get more or less the same tree. Maybe with some exceptions. These numbers are sort of very strict. It has to be precisely like that after that, or precisely the same like in this case. It is in 55% of the cases, precisely these languages were following this branch. These are some sort of Slavic languages. And this picks the most used edges. But you can see that the tree looks more or less the same, and it gives kind of typologically meaningful and nice results. So 50 samples is more or less the same, more or less enough. We done. I forgot to put the acknowledgement. I'm going to show another picture from the same paper. When it's published, you can look at it like there. We put another sort of argumentations. How many samples do you need? When you you evaluate the entire. You sort of build the thing on some selected number of samples for each language. You build the embedding sort of system. You can calculate distances between any pair of languages. And you can do that. You can subsample the data set many times for even as little as 20 samples from each language. And then you can calculate always for each of these subsampling. You calculate all the distances between those embeddings. And you see how the distances overall, this would be 100 languages, so 10,000 distances. How these 10,000 distances correlate with each other depending on a sample. And we get very high correlations. 90% roughly we reach for these 50 samples, and we reach over 70 for as little as, I don't know, 15, 20 samples. So it's quite robust. So the basic characteristics are captured quite well. Basic distance are captured quite well. Of course, this is not some sort of rule of thumb that 50 samples is enough. Or it all depends on what your data looks like. How much unwanted variation, as we were talking, the source of unwanted variation you have there. How balanced these things are. These are actually rather pessimistic scenario. These were not really balanced in any meaningful way. So 50. It's surprised that the 50 would be quite good already. 50 samples. These are 50 utterances from the languages. It's really quite impressive. So it's 100 languages, so it's 5,000 samples from all around the world, and it sort of can create a typological map. I would be careful to present these type of results on some linguistic typology conference. I might be booed and thrown out from the building. So now maybe the kind of most burning issue is the sort of type of questions we can ask using this type of method. So this is good, as we have tried to see, this is good at sort of quantifying the effects of all sort of sources of variation, which are sort of difficult to quantify in any other way, right? Like, for example, if you have 100 odd languages from around the world, and you want to assess their typological relationships among all of those, this is tough. This is not even really well-defined question, because where do you start? What will you, like if you have two languages, it's fine. In particular, if there are two sort of related languages, it's sort of doable and done a lot. What type of, does the language use suffixes or prefixes? What is the, order of in the clauses and some grammatical things. So you need to extract some features, the same features essentially from both languages, and then compare them, how they are realized, right? But if you have 100, for each pair you have to identify a set of the same features. But how do you do that in 107 languages? Are there even any features which are shared among 107 or all languages in the world? As a matter of fact, no, there aren't. This is the fact from linguistics. This is where sort of the Chomskyan thing went to be this completely minimal theory, which sort of claims or had only one claim, because every other claim they made has been disproven. In structural claim they made has been disproven, and some counterexample was found. So this is tough, to do typology on all world languages. It's sort of not possible really. So that's why this is a good technique for that. You might not kind of really know what you get, what, why, but you can do this quick analysis, and then maybe you can start grouping the languages into different sort of groups, classes, and then maybe start looking inside painstakingly and start comparing, or start figuring out why would, I don't know, there were some surprises here. Maybe they kind of dropped out from the why would Maltese be actually classified here among all of these Mediterranean Europe languages? Of course, geographically it makes perfect sense, but of course Maltese is a Semitic language, very different. Of course, what type of features are making it sound a lot like Portuguese, as a matter of fact? So then you can start looking into characteristics. I would bet that it's probably prosody and phonetic realization of the things, because this is something which is borrowed as opposed to structural. So this gives you many questions you can start addressing. But so this is probably prosody, but maybe this particular relationship here somewhere then is actually some sort of slightly different phonotactics maybe, or some other type of things. So again, you can get hypotheses maybe for this entire group here. You might find some features which you can analyze together, but maybe not for all 107 languages here. So these are good sort of, well, let's put it bluntly. This type of method we kind of came up with is really good for calculating distances among things, because we come up with numbers, come with vectors, and for vectors we can calculate distances, among other things. That would be another, just occurred to me now, as a mathematician. We can do a lot of other things with vectors than calculate distances. Maybe there's something to look into, some orthogonality among things. What would that actually mean? Well, we'll leave it for later. I haven't thought of that. So we can calculate distances among sort of languages and dialects, as we did on the previous slide, and we did it we have shown some Finnish dialect things, and we did our language comparison and the accent in English. Sort of we can see the sort of dialects of English, maybe of Indian English and all that. But we can also do things on a little bit. I unfortunately didn't spend a huge amount of time sort of on this methodology, explaining things with which are a little bit more targeted. For example, this comes from very small database collected here about 2 years ago. These are Angami tones, if you are wondering what they are. So these were, we collected the database, some recordings from, these were all, and Janine can correct me if she remembers better, or if I am completely off. We collected the data in sort of, one understand it's sort of standard Angami. Angami is spoken mostly in Kohima. And sort of people recorded, was it North Wind and the Sun perhaps, I guess? Was it the North Wind and the Sun maybe? Or?
No sir. It was some target words.
Yeah. Oh yeah, this was actually, yes, that's true. This was sort of target words. And no, I'm not sure. Yeah, anyway, some text. And then we labeled oh yeah, so this was some sort of target words from, no, but this was different. This was not a dialect. We did this extra thing where we coded some little text. And this was in standard Angami, and we asked the people from Kohima, well, maybe one or two, and from Jotsoma and from Kigwema to sort of read this text. So this was not necessarily about the Jotsoma Angami or Kigwema Angami or Kohima Angami, but sort of Jotsoma accented standard Angami. So we had the same-ish text, and there we labeled the tones. So they were technically the same phonological tones, because that's what people were used to. So they didn't, change the tones. Well, they changed them phonetically, as opposed to, they read the words which they might not use in the standard language, but in the daily language, but which was sort of the way how people speak in Kohima. And then so we annotated them. Well, this is this sort of royal we, they annotated them. And then we built this was this generative system where we trained these local conditionings on these three dialects. So it was sort of trained to produce this kind of only F0 and intensity based signal. And you see, I was saying when this conditioning, you can do this global conditioning. So you say that generate me the entire utterance in Hindi. or generate the entire utterance in Jotsoma Angami. But here, we said like, you know, from here to here, generate tone 1. And by the way, this is Kohima Angami. And this is tone 4. So when the synthesizer, as it were, was generating, it was called local conditioning. Every now and then, it was told from here to here, next sort of several samples, generate as if this is that type of a tone. And we train these embeddings in the same way as we train any other embeddings. These are local embeddings. So we had sort of 3 dialects. This A always stands for Angami in an unimaginative way. And then Jo is Jotsoma, this is Kigwema, and Kohima. So we got representations from these 4 tones, from these 3 dialects. This was a very small database. We did it in one afternoon in Helsinki together, this analysis. And this is what we got. So I really don't know whether this is any good, but or anything groundbreaking. But you can see that from right to left, more or less, you go from tone 1s towards the tone 4. By the way, this seal here is actually not silence, but it's an embedding for anything else, which was not tonal in the speech. Whatever, every portion has to be locally conditioned. So we had this, and you know, this is not a tone, something else. So this is what gathers everything. But you can see here, maybe you can start reading. So this is essentially tone 1 branch here. You can see that Kigwema and Kohima tone 1 is sort of branched together. But and this is Jotsoma tone 1, but somehow the tone 2 from the Kigwema dialect sort of peeks into this tone 1 it sort of lumps together with the other tone 1s. Of course, it's distinguishable from tone 1 from Kigwema, but it's actually a lot like tone 1 in Jotsoma. So I don't know whether there is some tonal shift. Of course, this is only really, we had like, I don't know, 5, 10, 15 speakers, or 10 maybe, so maybe not even, I don't remember. And here are the tone 2s here, but again, they are sort of mixed a little bit, you know. Tone 2 and tone 3 from Kohima, sadly, are sort of difficult to distinguish. But here are the tone, and tone 2 from Jotsoma. So tone 1 of Jotsoma is down here, tone 2 of Jotsoma then is a little bit like tone 3 in the other languages. And tones 4 all come here. So tones 4 are clearly distinguishable, and there is a little bit of a mix-up between tone 1, tone 2, and tone 3. So you know, how generalizable these things is difficult to tell. This was a small, very model sort of study, a lot like our own analysis. I guess whatever cute and cool results we got yesterday, I don't think we are going to publish it in Nature tomorrow. But if we want to do more of that, you know, this is the way to go. So this is something very similar. But it produced meaningful results. And these are results about, again, sort of phonetic dialect realization of tone, smaller units than just sort of like languages, dialects, and what have you. So you can do that as well. This is, by the way, the very similar technique to the one which we used for the Swedish dialect classification. So if you want to know more, maybe that would be the paper to look at and to read. We have also some similar papers to this when we use local conditioning on the dialects of northern Sami languages. There was a big database and we compared all sort of other tonal things. So you can compare not only sort of entire language dialects, but other maybe more fine-tuned tonal, prosodic, quantity, whatever. Of course, vowel quality, you know, all those type of phenomena among dialects, languages, local sites, and what have you. Now, we were talking about the results are difficult to interpret, but of course it wouldn't stop us from trying. So this is one of the examples of trying to interpret the results which come up from machine learning beyond drawing the dendrogram or putting things on a map or maybe making some sort of projection of the LDA first components or PCA components. So it's something slightly different type of analysis. So these are those world languages, I think all 107 of them and all that. And there's many more dots than 107, as you can see. So there is a dot here for every pair of languages. Because of course the embeddings or the sort of the latent representation of languages are whatever 512 dimensional vectors or 1024, I don't remember, big ones. But distance between them, and we know that you can define distance between two vectors, is just single number, right? So we have roughly 10,000 dots on this figure, which each represents a distance between a pair of languages, right? So we had this big database essentially of distances of single numbers. And then, of course, we also, with all of those caveats we were discussing yesterday and Tuka was talking about and I was repeating today, also get the similar type of, well, same size of thing, of the distances in terms of geographical distances between the languages. So for each pair we have the embedding distance between how our system perceives, what is the distance between these two languages in terms of how they sound, and then also geographical distance between these sites, right? And then a third thing, we looked at we wanted some sort of typological distance, some sort of traditional typological distance. And there are some measures, there are some Python libraries, surprisingly, which can give you, given ISO codes, all of the results from pre-trained models. And one of them is the lexical distance, right? So this is built on some type of word list, I'm not sure, some Swedish or maybe something bigger, some list of some sort of Levenstein distance between different words. When you have two sort of strings, you can somehow calculate the distance between these two strings. Yeah, there is some particular way. It's called Levenstein distance. Yeah, it's a more or less sort of how many replacements you need to make in order to make one string like the other. So there is, and of course you can then average it, and these people know what they are doing. I really don't know what they are doing, as a matter of fact. Lexical distance. So it's a sort of measure, rough and ready measure of sort of family distance between two languages. So if we have very closely related languages, this is going to be relatively small, and if we have very distinct languages, this actually, as a matter of fact, would be sort of infinite, because the languages come from very different families. This just doesn't work. So there is some random value they put, I think, to yeah. Mm-hmm. Because of that, now I needed to check my slides, so I have to roll back a little bit. I said we have 107 languages, and so this will be 10,000 dots here, but there isn't. Because of this lexical distance is meaningless between the languages from different families and actually undefined in this particular library, because there is no way of getting the word jeden, which is one in Slovak, and word yksi, which is one in Finnish, somehow together, or they gonna decide that whatever there is would be coincidental. Those are languages from different language families, so, Indo-European and Uralic. So these are only the distances between the languages which are from the same family, right? So there is a lot of dots because we have a lot of Indo-European languages in the database. So like more than half of them are Indo-European, so this is like if there's 60 Indo-European languages, so it's 60 by 60, whatever. So there is that many dots at least, and then fewer number of dots for the other type of languages. So we have the embedding distances, and on one hand, and then we have the geographical and lexical distances. So what we did was we built a normal standard linear regression fit to how well can we predict the embedding distances from a combination of geographic and lexical distances. Normal linear model, embedding distance is a function of the geographic and lexical distances with interactions, right? So the fit was pretty good, as a matter of fact. I don't remember precisely, but overall, because we did it in many ways, again, hopefully the paper will get published so we can have a look. But the R square of that fit was something in a level of 70, 0.7. So it's very predictable from these two effects. So it probably does some typology, Both of those influences were significant and positive, meaning, the more geographically distant 2 points are, the bigger the embedding distance. The more lexically distant are, the bigger the embedding distance. And And the interaction was also significant. Interaction was significant in a sense that for more closely related languages, so for the languages with the less lexical distance, the slope dependence on the geographic distance is steeper, right? Which means that for more closely related languages, it matters more whether they are geographically close or further than for less related languages. By the way, the fact that the embedding, this is important note, actually I don't remember whether we made this in a paper, and maybe we can add it even as a revision, that the fact that the embedding distance correlates well with the lexical distance does by no means mean that somehow the embedding contains some lexical information in them, right? It doesn't mean that. It just means that they probably correlate both of them together well for different reasons with some sort of familiar relationship between the languages, right? So the lexical distance doesn't mean that exactly the same way as that somehow the embedding would contain some geographical position of those things. That would be ridiculous. And would see equally, probably slightly less, but probably equally ridiculous is the fact that they would contain some lexical information directly there, right? So you can see here, because this is two-dimensional fit and we didn't want to put two-dimensional picture, so we did try to put it in one dimension. So the geographical distance on the x-axis, so these pairs here are close together. For example, this dot here is Norwegian and Swedish. And these two, the pairs, the dots here correspond to the languages spoken geographically far apart, right? And then the coloring of the dot depicts the lexical distance between those two languages. So if it's a dark one, if it's a blue, then they're close. And if it's a sort of light yellow, then they are far. So you can see that, the embedding distance, you can see that the color of the dots, well, we can see first of all quite clear relationship, quite clear regression line, that that the embedding distance depends on the geographical distance. There is a bending, but the bending is there because the interaction. There are more blue points here and more yellow here. So the closer, the more lexically related, the closer embedding in general distance. You can see that Hindi and Urdu, actually, as a matter of fact, are here. They are the lowest most point in terms of embedding distance. The embedding distance between Urdu and Hindi were the closest in all entire database, and it's also the kind of the bluest point as well. So the lexical distance is probably close to 0, as a matter of fact. So, and here you can see that because interaction is difficult to plot in these two things, but this is sort of, there are these 3 regression lines, and these are 3 regression lines for different lexical distances, roughly. So if the languages are lexically far away, then the fit is like this. The fit between embedding and geographical distance is like this, not so quite shallow. Then if they are far away, the similarity, embedding similarity, is not so much dependent on how far they are geographically. If they are more closely related, the slope is steeper. This is the interaction in that model. If they are closely related, the slope is steeper, meaning that for closely related languages, the dependency is stronger. And here we plotted all sort of outliers. These are the outliers. These are the pairs. These are handpicked more or less. I think we generated like 50 or so, the outlying pairs, and then just sort of handpicked so that we can actually fit them in a picture and they are not on top of each other. So they are not completely handpicked, but we just sort of for graphical reasons. And you can see that, so these up in green, these are the pairs for which the embedding distance was actually closer than predicted from geography and relatedness. So for example, Hindi and Urdu. And one can go through all of Norwegian and Swedish. One can go through all of these pairs, more or less, and realize why that would be. One of the obvious one here is Afrikaans and Western Frisian. Afrikaans is the essentially descendant of Dutch, spoken in South Africa. Western Frisian is descendants of Dutch, spoken in the Netherlands, in northern Netherlands. So they are, of course, lexically very, very close. The embedding distance is really, really low, but the geographical distance is massive. This is a result of colonialism, of course. There would be few other examples of that. English and Irish is one of those examples where the embedding distance is actually really low, but they are lexically very distinct. So again, the embedding distance would be lower than predicted by the other things. And here on the top side here are the outliers the other way around, where the embedding distance, the distance between how the languages sound, as if you wish, is bigger than predicted by the interaction between by the effects of the geographical and sort of family distance. One of the notable pairs here is Assamese and Northern Kurdish, right? So they clearly sound more different than you would think, essentially. That's what it is. So that means that they are lexically actually quite far, also geographically quite far, but they sound yet more different from each other than you would think, right? I have no deep insights into Assamese and Northern Kurdish, but maybe you know why that would be. So they are, I guess, both Indo-European languages, but really the history is quite far. Funnily enough, there was not that many other Indian languages up here. So Assamese, of course, is the sort of easternmost Indo-Aryan language, I guess. And Kurdish, I don't know, it's probably not Indo-Aryan language, or is it? I don't know, is it? Yeah. So it's probably the westernmost Indo-Aryan language, so Tuka was nodding feverishly. So maybe, they are as far as it gets. And with very different influences, of course. With Assamese might have influences from exactly northeastern languages, for all we know, and Kurdish most likely Semitic languages and Turkic languages. Mm-hmm. So yeah, so this is something like we could spend a lot of time looking at that. Almost every pair you find being somewhere strange has a sort of history, and can be interpreted. So this is what I was trying to say. It's not completely, we end up with these distances and a bunches of numbers, but it's not that we cannot sort of do some further interpretation. We always come with some idea and try it, and how to. This is again visualization, but there is a bit of analysis. We can put numbers on these outliers. This is not just sort of looking at where they ended up on the map, but we can put like these are this much different, and then they should be predicted. Mm-hmm. And the fact that this fit is relatively strong and relatively robust, as I said, it's in an order of 0.7 R square. So the correlation is sort of even higher between predictions and the real values. That for us means that we are doing typology, after all, of some sort. Yeah, there is one more little thing. I'm going to a little bit cheat here with this slide. So take this a little bit sort of metaphoric, because anyway, I'll tell you why. So remember that I'll just copy this picture from yesterday or whatever, where this is our pipeline, where we throw in the signal and goes through these contextual WAV2VEC embeddings, and then we run it through the language identifier. And I said, we gain the fixed length vector. Like from here on, these are fixed length vectors. This attention layer makes sure that it pools them together, translates the sequence of vectors, sequence of any possible length, to summarize them in a single vector, and then we do some processing steps here. So, but when I said we take the fixed length vector from here, because that's just before the kind of probabilistic prediction is made by the network. But of course we can plug the network anywhere, earlier or later. We can see how these particular things look, how these things look, right? So we would assume that this first layer, before all these processing steps, as I said yesterday, these processing steps, these are convolutional processing steps, if I remember it right. So they mean that they turn one type of a signal to the other. They sort of multiply it and turn it around and put some sort of this is sort of a lot of filtering, as it were, on these vectors. So you would have thought, so there's a lot of kind of filtering which is designed to grasp these features which are relevant for language identification going on here in these processing steps. So you would have thought that this first layer contains a lot of information about the signal itself, sort of kind of, yeah, signal-based information, while as you go further down, this last layer is sort of fine-tuned to contain a lot of information about the sort of, typology of the thing, what all the information is relevant for making decision from language it comes. So you would have thought that, that as you go from left to right, you lose the signal, the information which is in the signal, and it's replaced or transformed to the information which is relevant for the decision, right? So in theory, so we can pull the vectors from here and from here, and what you can do is you can extract from all of these utterances. Now you can put back to your phonetician and signal processing type expertise hat and extract all sort of prosodic features like we normally do. F0, standard deviation of F0, I don't remember what else. MFCC coefficients, voicing amount, whatever. There is actually even a standard set in signal processing world of these 128 or whatever features. So we did that, and then you can check how well these different features, or how well these vectors predict these different features, right? Again, using just simple linear regression. So the feature value, so standard deviation of F0 is the one number, and you have like 512 values of the vector. Can you combine these? Can you fit the linear model which predicts from these vector features this particular prosodic feature? And you can measure how well it does it. So from that you get some sort of rough measure of how much the F0 is actually contained in this latent vector. If it's an easy task for the model to predict F0 from the given vector, then the vector must contain the information somehow encoded. If it's a difficult task, then that information is lost. So we did something like this. This is where I'm cheating a little bit, because we use sort of slightly different machine learning technique, actually, as a matter of fact. So we didn't extract these layers from exactly this type of the machine learning system, but from the other one, but very, very similar. Yes?
So how do we implement that, like extracting information from between the layers?
How do we manage to extract the information between the layers? How do we extract those layers? Well, this is purely sort of technical question. So it depends a lot on the type of implementation you have. For example, we use PyTorch implementations of these type of things, and in PyTorch it's actually very simple, because there is a very explicit processing, this forward processing way of the network, and you can literally just return the value which exists in the networks at some point, and you just sort of store it. In TensorFlow, it's slightly more complicated than in the other Keras. It was, I don't remember, maybe easier. No, maybe even more. I don't remember. So this is just a programming question. This is a question of programming. When you run the network, you run the computer program. So when you run the network, it's not some magic happening somewhere. You're running a computer program which takes this as some variable, fits this as a variable, and produces new set of variables here, a new set of variables here. So we just spit them out like from a normal program. When you calculate, when you run the Pratt script, we of course kind of at the end stored things in some table, but we had some values in the Pratt script which we could have printed out as well on the run. So this is very much like that. You literally just spit them out, just return them and store them in some database. So that's how you do that. We have, of course, these big vectors, and then you try to predict using very simple linear regression, try to predict prosodic features. So you have 1,000 features. How can I predict this one number from these 1,000 numbers? And this is what we got. So this is, you can see, these actually much smaller dimensionalities. These are different. There is a paper, you can read it. But in principle, it's a very, very same thing. We could have done it here, we just didn't. We did it in another paper on the Finnish dialects. And what we get is this. Look, these are the acoustic measures. So speaking rate, F0 mean, F0 standard deviation, spectra tilt. It's a measure of the sort of softness or harshness of the voice. Remember the first day we were talking about the slope of the declination in harmonic sound, how slow the energy sort of dissipates with the harmonics. And then this was average F1, average F2, average F3. This is how rough the measures are, you know. But you can see this is R square. R square for the linear regression is a predictor of how good the fit is, how reliable the fit is. So it goes between sort of 0, as a square between 0 and 1, and more closer to 1, the more faithful the fit is, the better at predicting the dependent variable, the independent variables are. So this is very high. All of these are very high. It means that it can predict. So this is actually some sort of square of the correlation between the predicted values and the real values, right? So this is very high. So it means that this layer here from that layer you can predict all of these acoustic characteristics very well. So this layer, the first processing step, this wave-to-vec encoding, actually does contain information of all of these things. So at this step, it's there. But as you crunch it through the, give me what's relevant for the fine-tuning, for the predicting what language it is, it contains that information much less. They are still relatively interesting numbers, but they are much lower. So that this last layer does not necessarily always contain the huge amount of information about F0 mean, standard deviation, speaking rate as such. Or does contain it, but much less, right? This is actually sort of run in a slightly different thing. So this would be, we extracted it, we built this actually might be relevant here. I didn't try to talk about it for those of you who are interested. We actually build this combination of these wave-to-vec and classifiers. So we build essentially for Finnish dialects, separate classifiers for each pair. So we're like 14, so we're like 14 square classifiers. I don't know how many took train them. And this is so, and for each of these many classifiers, so these are binary classifiers between two Finnish dialects. For each of these binary classifiers, we did this procedure. So that's why you have this standard deviation here, which means that, this is the average across all of those pairwise classifiers, and this is a standard deviation here. You can see that these R squares are really all of them really high, and the standard deviation is minute. So this first step really didn't do much in terms of processing. They all pretty much contain, all of those many classifiers contained roughly the same amount of information about these acoustic features, the prosodic features. And here you can see that these numbers are lower, but the standard deviation is much higher. For example, for F0 mean and F0 standard deviation is 0, it's like more than that. Which means that for some pairs that needed to retain this particular information, and for some other pairs it didn't need to retain that information. So this would be one of the first steps, how to start a little bit unearthing what's going on. We could have, and we might sort of start looking into, so for which pairs of Finnish dialects F0 standard deviation is actually important, as opposed to which. And then we can start creating hypotheses that, maybe for these two dialects, or these two dialectal groups, one of the main sources of difference is F0 standard deviation and things like that. Of course, we can build many more features. So it's not all doom and gloom. There are ways to kind of start poking and analyzing what's really going on. There's little, ways of peeking into the black box. And exactly as your colleague asked, there are ways to peek in the black box because it's black, but it's not so much of a box. It has a lot of holes, so we can let the information leak out from that. And we can exactly pull all of this information if we want from that, because it's a program. So in future, of course, we need more and more and more effort into this type of opening the black boxes. So that's your job, by the way, mostly. Sorry to say. Of course, this is not particular concern particular to the field of modeling linguistic diversity and prosodic typology with machine learning, but to the entire massive field of deep learning and artificial intelligence. Just think of large language models. Those are big black boxes. It's of almost matter of survival of human race to try to reverse Unitarian a little bit and know what's going on, right? And all of the AI things. So if you start kind of bit by bit opening the black box in these type of ways, you're not going to be on your own. There's loads of people who are trying to do just that. So there is a lot of methods, a lot of new discoveries, a lot of new ways coming on every day, how to analyze, how to little bit try to open up the black box and peek in. We talked about this earlier. This is just something which is like super important to reiterate, is that we need to remember the other issues. So we have this black box issue, which is sort of security and ethical issue on its own. Security issue because if the AI systems start more and more dominating our daily life and we don't really know what they do, it's not so good. Of course, in particular because we have very short, we know what they do, but we know how they do it. It's not very good because we have short time to adapt to that. Like I would say they're very similar with the elephants, which are very useful tools, but it took thousands of years to, and we don't really know how they really operate that much, but it took thousands of years to sort of ease them into the society bit by bit, while these took a couple of years. So it's the same type of a tool, same type of a black boxy tool we don't understand, but so we need to open it up. So it's a security issue and privacy issue as well, because who knows whose data is actually there and who knows how they can be recovered. When you ask ChatGPT some question, who knows, maybe it's actually directly copied from Secret Thoughts of Priyanku Sharma, which he put on his phone and the Google stole it. We don't really know. All of these things are relevant. But of course, for us as speech scientists, we need another layer of security and privacy because we are working with the human biomarkers. We are working with something very similar as DNA. So this is a medical conference with people, sort of physiologists, and we are now collecting and analyzing DNA. It would be trivial that we have to be a little bit careful about that we just can't just leave it or pour it down to the canal when we leave or something like that, or give it out as a present, to the passers-by. So this is a little bit similar. Well, this is a lot similar with what we do here. We also collect biomarkers, so we have to make sure that we're talking about this. We're talking about some principles and some in some sort of detail, but we always have to be aware that when we work with these deep learning things and with a lot of data, we have to remember that we have to be extra careful to how we share and how we process those things. So we have to remember, and this is easy to say as a matter of fact. I do say it every now and every now and then I sort of do something like collect the data from all of you and go a little bit like, sure, it's gonna somehow we're gonna get away with that. But but it's still good to. It's easier said than done, as a matter of fact. I'm well aware of that. It takes a lot of effort. It's kind of costly as well, and it's a laborious thing. And of course, we want to, in particular in the situation of Northeastern India, we are not only talking about protecting the privacy and security of individual participants, but we are talking about their communities, because the communities are so small, sometimes so fragile, that we can really sort of make damage of which we are cannot even sort of start thinking what type of a damage. Mm-hmm. I remember I was in Kigwema and we met the local, representatives from the village, and they were very, very, very friendly, very helpful, super welcoming. We were talking, having some tea, and then we prepared to ask, like, what are you doing? Try to explain why are we recording this, what are we training the students about, and they of course asked extremely well-educated people who actually were we had a very nice debate about that. But then they asked me, like, so what is in us? What is in it for us? Not like, give me something, but what can I tell to my fellow villagers that why I welcome these people in the village? And this is a tough one, for me. So of course, everybody has to come up with some answer. But it's good to be aware of this answer before you go to these communities. So they will ask you, and they have full right to ask you. And it's our full duty to be able to answer that. And if you don't have the answer, maybe just go home. So using standard methods like, what about prosody? So we were talking about that a little bit, Using standard methods like classifiers might be actually better for addressing sort of well-defined questions in prosodic analysis and other things. We saw the Swedish example, Angami example a little bit. We can also use deep learning methods if we have a lot of data, a lot of interesting data, and we don't really know how to perhaps, for example, this Angami example would also work very well if we didn't know how to conceptualize the Angami tones. Now we know that they are all-level tones, so we know that we can conceptualize them to some level by sort of F0 in the middle of the tone. But if we didn't know that they were level tones, this technique would work equally well. This is agnostic. So this would be the example where we might analyze some particular prosodic patterns which we don't know what are the right features to characterize them. If you have falling tones and all sort of dynamic tones, again, you might have Chinese rising tone or something like that. So now you would go, okay, so I need some F0 at the beginning or in the middle and some slope. But what if the tone is in some language like that? You have to then kind of how many plops there are. Remember the Swedish actually, accents which were not just falling, rising, or they were kind of rather complex tones. So then, how many kind of parameters you need to characterize that? So, but these techniques you can use when you're agnostic to these. This is what I meant by this theory bias, as it were, and theoretical preparation. But of course, we need a little bit more data. This is some speculation here, which sort of arises sometimes in our lab and with our discussion with Priyanku, and actually here it arose as well. Then maybe for these large kind of multilingual comparison, if you want to do the prosodic typology on the world languages, this is sort of difficult because we need to remove the non-prosody from that. So one easy way would be to sort of delexicalize all of those recordings. So there are many ways how to lexicalize them. They are, you can just low-pass filter them to some extent, or you can do the hum in Praat, or we have our own hum which you can create, or you can actually get the inverse filtering and get just the vocal source, or whatever, just to make sure that you keep the only sort of prosodic relevant characteristics there in the signal itself. And then you can run it through the pipeline as we did. Afterweg, all of those. Summarizing language identification. What's the problem with that approach? Why did we not? Because this is something Tuka can do in overnight, because it will probably take overnight to delexicalize all of those characters, but then another overnight to run the train the network. So what is the problem? Why are we sort of really a bit hesitant, or rather, we will do it actually next week or so, but I'm a bit skeptical about that. What is the problem with that approach? Oh yeah, after delexicalization you can say that only prosodic information remains. So it would be sound which sound like you can keep all sort of things. It's sort of like essentially only obtain the source, the voice source information, which contains most of the what we would call prosodic. So yeah, all the tones, all the pitch would be there. So and there would be no as, es, os, and kus and lus. It would be just no segmental information, but purely the prosodic information. So that's fine. So we would, if we got some results, got some clustering, and got some things, we would be sure that it's only prosody and nothing else. That's as easy. But what is the problem? Would we get this sort of good dendrogram? Maybe. Why am I doubtful? Remember that we are working with these pre-trained systems. Like the wave-to-vec is a pre-trained system. And then language identification network is a pre-trained system as well. So wave-to-vec is pre-trained system on human speech, not a pre-trained system on delexicalized speech. We don't know what it will think of that. It will think of that something. It's a computer program. You give it inputs, you get outputs out. It doesn't kick you, or doesn't start sulking or saying like no. But how can we rely on those numbers? We don't know what it is. And of course, does language identification, the second step, that's not trained on delexicalized stuff either. So we don't know. Of course, the wave-to-vec is something which we cannot really retrain on the anything. It's just so big that you need to be meta to retrain that. But the language ID thing, that's a small network, we can retrain that. So we might try just about that. But of course we still are at the mercy of what the wave-to-wake make from this signal it is not actually meant for. It's not really trained for. So this is one of the issues with these type of things. But it's worth a try. You can beat us to it if you want, and we see what happens. Now, there are a couple of slides before we hopefully start you discussing about this sort of linguistic diversity in India. Like one of the things about the specs of this lecture was to talk about Indian context. I'm not sure whether I'm like qualified Central European mathematician coming to tell you about the linguistics in Indian context. Maybe it's a bit cheeky. Priyanku is there to kind of keep me on a path. You can shout when I start talking rubbish, but I don't have huge amount to say, I guess. Of course, for me, I can see from sort of distance what I can see here and what I don't see elsewhere, right? Of course, there is a lot of somewhat less explored and under-resourced languages. Priyanku himself, almost every day, he mentions that he has some data somewhere from some language of which I haven't heard of, you know. And we've known each other for years, so imagine how many languages he's thrown at me over those years. And they keep coming, you know, new ones. So I have no clue. If somebody asks me how many languages how many people like you speak around here, it's just a lot, you know. So this is super cool for, you know, these are main ingredients to be able to study linguistic diversity, that you have linguistic diversity, and we have plenty of that here. Of course, there is also kind of rather interesting phenomenon in India for me. So this is clear-cut. This is one of the, like, northeastern India is one of the, like, unique places in the world. There is maybe 5-6 places like this in the world, like Papua New Guinea and Dagestan and a handful of other places where the linguistic diversity is sort of this magnitude. That's easy. And of course, what I find particularly sort of interesting is this sort of level of multilingualism here. This natural multilingualism. You know? As a European, I grew up as a European of my age, I grew up in this sort of country where everybody spoke only one language essentially. Apart from that, at school they taught us Russian because that was compulsory because there were occupational forces there, and then some other language, maybe English. But I learned English at school, and it wasn't like sort of real language, it was a subject, you know. So I couldn't claim, nobody in my society could really claim that they are bilingual, you know. We were monolingual and spoke some other languages, if you're lucky, potentially. And this was situation all over Europe, apart from maybe some exceptions, like in Finland where there are 2 official languages, but even in Belgium where there are 4 official languages, as a matter of fact, or 3, 4 maybe, very few people actually speak multiple of those. But in India, it's slightly different. Traveling around India, I always find it fascinating that 2 people meet somewhere. This Assamese person meets some auto driver in Goa, and they just, you know, figure out the language all of a sudden which they speak. I remember when we were taking the car from Goa to Dharwad, and Gautam was sort of chatting essentially all the way with the driver, and at the end I asked him, like, what language did you speak? And he kind of gave it a thought, and he's like, well, I think it was Hindi. The only thing is I don't speak Hindi, you know. But this is sort of deep multidimensional multilingualism. It's not that you speak a sequence of or list of languages of some sort. There is, you know, you figure out the code with anybody. I find this super fascinating, because this is sort of prerequisite to things like language change and creolization, which are really the most exciting things they are in linguistics.
So that is why, like, you know, some of the questions that we asked yesterday were so interesting. For example, like, you know, if you are surprised to see Assamese or Bengali in totally different ways, it is not surprising actually, because the amount of contact that has happened over the years, you don't know where they manifest there and whether they are, like, you know, these other like, you know, very family-based, or like, you know, Indo-European family-based or Tibeto-Burman family-based features, how well they are preserved. I mean, I guess that there are 2 ways of looking at anything. One with a preconception that they all belong to separate classes, and only if they belong to separate classes and in the purest form is what we are going to analyze. The other is that, like, take a very broad overview, right, and have a broad outlook and look at the data with no sort of bias, and then see where you go. So I'm more prone to, I encourage everybody to, of course, such kind of preconceptions are very important in our context, in the Indian context, but it is also important to have this unbiased and very open outlook in analyzing any sort of data, any sort of specifically, the linguistic data that we talk about in this country, and specifically in the very much under-researched languages.
Absolutely, absolutely. Yeah.
We don't know where the boundary has actually faded and where one is overlapping with the other.
Yeah, absolutely. We have this other kind of somewhat orthogonal debate with Priyanku and some other people from actually India and Finland and other parts every now and then, where, like, essentially, I'm not a linguist, I'm not a trained linguist, so I never been to a class in linguistics where somebody, the professor with authority, comes and tells me language is copy and this. So nobody ever told me what language is. So as a phonetician, I just try to sort of figure it out by some sort of osmosis. And I still haven't figured it out. I have no clue what language is. I know what human speech is. I know what utterance is. It's fine. But I don't know what language is. And of course, there are multiple schools of thought. I'm not the only one. And this was exactly what Priyanku said, that there is this sort of one way of seeing language as some system, abstract system with some structural properties. Or then there is the other way to see the languages sort of emergent patterns in human communication. So when you want to start talking about language, you start a lot like in our systems here. You start with the individual speaker, potentially individual speaker with individual situation, and you see where does it lead you. What are the common patterns when two people speak together, and what are potentially common patterns when this person speaks with this person here. So that's a sort of bottom-up way of looking at the language, and the language is just it's an unfinished, undefined entity, which is the tool for communication, and all its characteristics are fully determined by this function and this type of pattern of usage. But we are not here to do this sort of linguistic kind of philosophical debate. But the Indian situation gives itself, the European situation I was describing earlier, yields itself to the interpretation of separate languages as separate different structural characteristics. I was taught at school what Slovak was, although even that time I had doubts, because the teacher once came and she told us that whatever inflectional things we used in our local dialect is wrong. I remember we were like 11-year-olds, and we just like the recess break, we were like, she said it was wrong. Like, how is it wrong? Always worked for me, But we were told this is wrong, don't do that. Don't use that particular inflection. So there was already this type of, but that's sort of idea. The language, Slovak language, is this type of structure. But in India, this starts breaking up. It sort of starts going like, what is Angami language, as a matter of fact? That's the first question, like this starts breaking up. It's a collection of communicative habits between people. So this leads to very many very relevant questions. Sort of kind of interesting, sort of small. I don't mean small questions, but sort of very targeted questions. Small in the sense of a scope, to all of these broad philosophical questions. All of that is here, in my opinion. Of course, there is a lot of data here, potentially. A lot of people, essentially. So a lot of languages. The question is, how can we source corpora? With some of you, I was talking about this. We use some results from Donate Speech, Lahjoita Puhetta campaign in Finland, where there was this campaign run by our colleagues in the Language Bank and the State Tele, where they urged people to call in and donate their speech. And it was really advertised on tele and, for about 2 months or 3 months, kind of 2 years ago maybe. And and it really worked. Of course, there had to be some system which received them and generated some questions for them and recorded them and stored it safely, stored metadata safely and all that. It was some app actually. So there is a little bit of work. And of course, there was probably 5 engineers which made the app, and probably 15 lawyers who were checking that everything is sort of right and legal and secure. But that was relatively easy, and it was super efficient. We ended up like with thousands of hours of speech from all sort of people who we couldn't possibly get to the studio. So who knows? Can we replicate some? I'm not even sort of thinking the all Indian campaign. They will be crazy now, you know. Potentially even with, I don't know, legal situation, maybe even the legislation around the data storing might be state dependent and what have you. But you know, there are so many, you know, like Assam wide or Goa would be something you can think about. Maybe that would be cool. Of course, even this type of crowdsourcing and having this type of data, ending up with data, requires a lot of work. This is what's super interesting and important, like these almost last words I have to say here, super important for this course, that you might have sort of understood something better and maybe something somehow less well something else. This is fine because this is multidisciplinary effort. This is a multidisciplinary field. You know, this takes linguists, phoneticians, machine learning specialists, computer scientists, and who knows, you know, signal processing people, lawyers, as a matter of fact, administrators, millions of people. This cannot be done on your own. We don't do it on our own, of course, you know. So, of course, so we have to be aware that, you know, I will not understand every little corner. Important is this is what we tried with this course, and we don't know, we'll see whether we succeeded, to kind of give you some rough idea. Not necessarily to understand everything, but rough idea that there exists something which I don't understand, but I roughly know how to use it, or perhaps roughly know who to ask. And of course, in India, all of these people are available. In IITG, all of these people are available, as a matter of fact. So this is another kind of great things around here. This is not necessarily the case in Finland, that you can get an easy conversation among, and you can source many people from different disciplines. Yep, that's it actually. This is the thing which I sort of said about that. Let's do this little discussion. I'm just gonna spec it, then we can take a little breather, and then we can start discussing. So what I want you, this is what we do a lot in Finland in general, that we want you to sort of form little groups of 2, 3, 4 people or whatever, how many you want, and you might want to sit with your close friends, or you might want to kind of venture somewhere else. It's up to you. I'm not gonna be deciding who you are going to talk, and sort of a little bit have a chat about these things. I know that many of you are sort of full of ideas and have a lot of questions. So maybe you discuss them a little bit among yourselves. And I want it not to be sort of like, oh, that's what he said there, like that, you know, interesting. But literally think about your own work, your own questions, and communicate them with the others. Think about your projects. How can maybe be possibly addressed by what aspects can be addressed by machine learning? What knowledge would you need? How would you obtain that? Maybe some people have some knowledge and some other people have some other knowledge and some other people have some other type of knowledge, and maybe you can even maybe find the knowledge you need to progress in your master PhD project right in this room. And I would say that it's not super likely that it's actually me or Priyanku or in particular, you know. But there's probably somebody else in this room who actually is the most useful for you. Exactly, how to collaborate, what data you might need. Maybe somebody has, like Priyanku always has some data sitting on his computer, you know, when we need some data. So maybe some other people around here also have some data which you might need. So let's a little bit take a breather. So let's reconvene. Let's reconvene in like 5 to 12. And then like 15 minutes, you find these groups, and 15 minutes you chat. And then I will ask you to little bit tell us what you discussed, briefly. 2 words. No, don't prepare any written report for that, you know. Just briefly. And if you say like nothing much, that's fine as well. Now, for the people who are online, this will be difficult. But we also want to have you to be involved in a discussion. So, because of course we were talking with the people who are here in person. We of course were talking even between the breaks, so they had a lot of opportunity to discuss things among themselves and with ourselves, which was sort of somewhat denied use. So in those 5-6 minutes, like Priyanku and maybe Tukka and Abhijit, if they want, and myself, will sort of gather around the computer, and please feel free to communicate with us. Also, all these type of questions, what you might be. So this is your opportunity to voice any type of sort of concerns or questions, and yeah, we will be here fully focused on the online participants during that time that the students are discussing things.